Hi and welcome to the next episode of Qt QML tutorial. In today's lesson, it's time to talk about integrating C++, commonly used for applications logic, with QML, preferred for UI programming. My name is Lukas Kosiński. I am the CEO of SciStudio, Qt QML consulting company. We help our customers achieve their objectives by providing them with skilled Qt developers. In Qt applications development, there is a very important concept. The thing is to separate applications logic, which in our case is in C++, from its appearance, frontend, coded in QML. In the previous episodes, we learned mostly QML features. Most of the magic happened on the UI side. And today, you will learn how to make a bridge between the backend and frontend layers. Let's go. Before we get into the technical aspects, let's consider why we should actually use the mechanism of exposing C++ classes to QML. When choosing a car, would you prefer a faster car, not very neat looking, or a slower but beautiful one? Well, opinions would be probably divided, but I am tempted to say that the most would choose the more beautiful one. However, there is no need to compromise. After all, you can choose a nice car with a super engine, and it will still look good. In the big picture, that's the main purpose of combining a beautiful QML interface with efficient logic coded in C++. Additionally, not everything that is in C++ is available in QML. A simple example would be calling native functions in particular system. For example, Windows API, Android API, or Objective-C stuff for iOS. Without C++, that won't be possible to accomplish. And sometimes such calls to native functions should happen after user interaction. And moreover, some Qt C++ classes are not available in QML, so you need to access them from C++ side. And finally, thanks to such a separation, our code is cleaner and easier to maintain. Okay, but how do we actually combine QML with C++? Well, it also depends on how you want to use the object in QML. We can create our own type based on QQuickItem or even plain QObject, so that we can create components based on it directly in QML. We call those creatable types of QML. We'll focus on them in the next episode, and today I will show you how to expose objects to QML. Exposing C++ objects to QML means that it's a way of making QML side aware of already existing instances of C++ classes. And thanks to such an approach, we can easily change the state of the UI depending on properties stored in the backend. For example, in C++, you can store all users' UI preferences, like for example, layout or dark mode. C++ saves them in a way that you like, in a file, in some configuration file, in database, I don't care. And you expose them using properties to reflect current backend state in the UI. Or in the C++, you can also modify, you can keep a model for storing and manipulating database data. You can make a class that accesses some native stuff, some electronics, some stuff like that. So how it's actually done in Qt, how to actually expose C++ object to QML. The first way may be to use a built-in qmlRegisterSingletonInstance function. As the name suggests, it allows you to register a selected instance of an object as an object with a unique name in the selected module. For the sake of example, let's say that we have a class company which has properties informing about the current income, expenses, and other essential information about the company. It could look like this. And wanting to access its properties, signals, and slots from QML, we must first create an instance of it in C++ before we load it in QML engine. Then, using a pointer to the instance, we register the type using qmlRegisterSingletonInstance function. The first argument is the name of the module. The next would be the major version of the module. Another one would be the minor version. The next argument defines how the singleton will be called in QML. So that's how you will access this object. And the last argument is an actual pointer to the object that we are exposing. So after that, in QML, you just need to use it like any other ordinary item, such as the one shown here in this way. There's also a second way to register a singleton. We can do it using our old good Qt add QML module command. Firstly, you need to add QML Singleton macro to your C++ class. And if you do not have default QObject constructor, then you need to declare a static method here that will create instance of your class. Then you can add CPP and header files in the sources in Qt add QML module command. And yeah, this approach is easier, but you have less control over instance of create a singleton from C++ side, as there is no direct access to static singleton object pointer. You would have to create it by yourself. And finally, there is also a third way. You can expose object globally under a given specifier using a setContextProperty function of QML engine's root context. And the steps are very similar to those we did in case of registering singleton manually, except now we do not add it to any module. It will be accessible in all dependent QML files under given name. The first argument here is that name, the name that you will use to reference the item in QML. And second one is the pointer to the object. Then in QML, you can access it via given string name. However, the approach with context property is not recommended. From perspective of someone looking at our only QML code, it might be unclear from where did my company came. Additionally, it may collide with some internal IDEs of QML, and it just pollutes every QML file. So in our example, we'll stick to the first approach, to using qmlRegisterSingletonInstance function, as it allows easier access from C++ and more controllable access from QML side. So how can we use the exposing system in our song player application? Do you remember player controller object that we define in QML? Well, as I told you, it's not a good idea to keep much of logic in QML, so we can now implement the very same controller, but on C++ side. To do so, we will create a new class named playerController. Inside, we will create Q properties like current song, song count, playing state. We'll also create slots to control current playback, and then we will create instance of our class in main CPP, and then we will expose it using qmlRegisterSingletonInstance function. And finally, we will need to get rid of QML Qt object and use our singleton instead. So let's do this. I will start by creating a new class named playerController. We do it as previously, just right click on the project, add new C++ class. Let's name it playerController. Let's make it basing on QObject. Let's change the case, finish. Here, yes. And we need to add it to CMake just by pasting the header and source file here. We save. And here it is. We will start by creating properties. I will use a split view and open main QML next to the other file to check how previous player controller looked like. Yeah, so saying about properties. First one, property, will be based on int type, and it's going to be named current song index. The second one is also going to be int based. It's going to be named song count. And the next property, the third one will be boolean playing. Now let's remove all write keywords, as those properties should not be settable from QML side. They should be fully controlled only from C++. Yeah, and now I will create a private scope for private class members. Yeah, and now we can use the shortcut Alt plus Enter to generate needed functions and members. We do it for every Q property. Yeah, and now we cannot forget about default fields values. So, current song index default value is going to be 0, song count is going to be 3, it's like fixed, and playing is going to be false by default. Now let's implement methods to control current player state. But first, let's clean it up a bit. So how do we implement methods in C++ and make them recognizable in QML? First way is to add Q invocable macro before method declaration, just like this. And the second way involves declaring our method under public slots keyword, just like this. Here we just declare a function slot. And in most cases, I prefer to put my methods, my functions under public slots keyword instead to using QInvocable macro. I do not like to pollute my header with unnecessary macros, but it's not a mistake still, and we will leave it as it is for the first one. In the meantime, I add the play pause method. Now we need to implement those methods. So let's use quick Alt plus Enter for each of them. and we are good to go. I will here rewrite those functions to have the same functionality as the QML equivalents. Yeah. However, notice that here I'm going to use emit keyword. You remember our episode about signals, so you should know what's the purpose of signals. And in QProperty macro, there is that notify keyword, and using it, you point to the signal that tells that this property was updated, but we also need to actually emit this signal to let QML know to get updated value. So remember about emitting signals. And now our class is ready, but QML is not still aware of it as we did not register it. So let's go to main CPP, add appropriate header here, header to our controller. And next we will create instance of our player on the heap. I will pass up as the parent. And next we need to register our class as singleton to expose the instance of object to QML. We do it by using qmlRegisterSingletonInstance function. The first argument is import path. Let's make it company player controller. And next we need to specify its major and minor versions numbers. Let's make it simply 1 and 0. And the next argument is singleton name, which will be used in QML. And so let's just make it player controller. Finally, the last argument is pointer to our object. Like this. And yeah, now we are ready to use our singleton in QML. Let's go to main QML and yeah, let's go to main QML and let's get rid of old implementation. Now let's search for its references in project and replace them with singleton usage. We can do this by pressing Ctrl plus Shift plus F. It opens advanced search menu. You can find more fancy shortcuts in Qt Creator cheat sheet. Here we write player controller. We can choose case sensitive and we look only in QML files. Yeah, and now search and replace. And here are the results. Let's check them. Okay, it's in order. Let's replace it with uppercase. Okay, it is done. We also need to add appropriate import that we define on C++ side. So import com.company.playerController. We also have to do the same in audio info box as player controller was accessed there as well. Yeah, and it should be working now. The behavior of our app should not actually change from the user perspective, but let's check that. Yeah, here it is. As you can see, we can still switch songs freely. You can pause, play, as it was previously. This way we prove that our C++ object is cooperating with QML as expected. So we did a lot to change nothing, but the point was to learn how to actually expose C++ object to QML, right? Okay, so to summarize, that's more or less how exposing C++ objects to QML looks like. Of course, there is also a matter of types conversion and a lot of other magic going on there. But today you have learned enough to integrate C++ and QML in most of the cases. Thank you for watching the episode. Please let me know how you like the series. Subscribe to our YouTube channel, follow us on LinkedIn, like the video. And yeah, that would be the best way to say thank you. In the next episode, you will learn how to instantiate your C++ classes, but on QML side. See you.